Good evening, students. In this video, let's understand how to simulate. Before we get into the actual video, this subject is called analog electronic circuits. The subject code is BEE 303. Okay. Now, in this subject, we are going to simulate some experiments in NI multisim 14.3. The first experiment here I am going to conduct, that is nothing but full wave center tap transformer type rectifier and then full wave bridge type rectifier circuits. Okay, what is the aim of the circuit? Let's understand the aim of the circuit. Design, simulation and testing of full wave center tapped transformer type and circuits with and without capacitor filter, determination of ripple factor, determination of regulation, voltage regulation, and finally efficiency. What are the operators required for this experiment is nothing but, okay, transformer 606 or 12 transformer we required, and then one number range is required, and then quantity one, and then DSOs, digital oscilloscope or cathode ray oscilloscope, and then probes 30 megahertz one quantity, and then digital multimeters one number, diode IN 1N 407 4 and 2 for center tap 2 for bridge 4, and then resistor 2.2 kilo or 3.3 kilo number 1, capacitor 4.7 microfarad or 100 or 470 microfarad, and then breadboard, or here breadboard is not required, for hardware breadboard is required, and some connecting wires are required. Okay, now let's understand the theoretical part of the center tapped rectifier. Of course, what is the purpose of rectifier? Rectifier will go to convert from AC to DC. In the half wave rectifier, we will going to use one diode, and then here in the center tapped rectifier, we will going to use two diodes. So why? What is the purpose of these two diode? Means in the negative half cycle also we will going to get some pulsated DC. In order to remove that pulsated DC, in order to get a pure DC, we are going to use the filter here capacitor. Here we are going to use capacitor as a filter for the center tapped rectifier. Now let's understand the circuit diagram here. Here input supply is single phase 230 volts 50 hertz AC supply, and then 12 and then this 12 volts is connected to diode anode, and then this 12 is connected to diode anode. In between 12 I'm going to make ground, and then cathode I'm going to short, and then here the cathode is to diode 1 or diode 2, where you can take anywhere from here or here. I'm going to connect to one end of the resistor, another end of the resistor I'm going to connect it to the ground. Okay, this is the circuit diagram explanation. Now understand the waveform. Okay, I hope your waveform is there. Now let's understand the waveform here. Yes, here there is a graph. Okay, very simple. The input is pure AC. Input is pure AC. Okay, 12 volts peak to peak, I hope. And then here pulsated DC. Pulsated DC. Here some pure DC. Okay, not 100% pure DC. Here we are going to get some pure DC. Okay, with filter. Okay, this is without filter. This is with filter. Okay, now let's see simulate the circuit diagram in the multisim. Before getting to the multisim experiment, I'm going to show you some calculation equations. So we need to find out find out the full load DC output voltage in the circuit diagram. 5.90, and then no load voltage is not required for the entire calculation. It is required only for voltage regulation find out ಮಾಡ್ಲಿಕ್ಕೆ voltage no load, and then Vm is equal to Vd into pi divided by 2. What do you mean by Vd here? 5.9 into pi divided by 2 ಮಾಡಿದ್ರೆ we are going to get 9.31. Im is equal to Vm divided by RL is equal to 3.98. Vm is equal to 9.31 divided by 2.2 K is equal to 3.9 into 95 into 10 to the power of minus 3 ampere. Vrm is equal to Vm divided by 2. Vm is equal to 9.31 divided by 2 ಮಾಡಿದ್ರೆ we're going to get 4.35. ID is equal to 2 Im divided by pi is equal to, we're going to get 2.5 1 into 10 to the power of minus 9 ampere. VAC is equal to Vm divided by 2 root 2 is equal to 6.13 volts. IAC is equal to VAC divided by RL is equal to 2.9779 into 10 to the power of minus 3 ampere. Ripple factor is equal to root IAC divided by IDC whole square minus 1 is equal to 0.48. Efficiency is equal to IDC divided by IAC whole square into 100 is equal to 80.93 percentage. Voltage regulation is nothing but VDC no load minus VDC full load divided by VDC full load into 100. VDC no load is nothing but 8.7 minus 5.93 full load divided by 5.93 into 10 into 100, we're going to get 46.7. This is the percentage. This is the voltage ripple factor efficiency regulation of the center diode with filter. Sorry, without filter. In future, let's understand the with filter. So for this calculation, we need to simulate the waveform. How to simulate the waveform in multisim? I'm going to tell you here. Okay, first we need to save the file. First, we need to open the multisim. I'm not here to supposed to tell how to open and all. Please follow the my previous videos in the channel. The playlist, I hope simulation of op-amp circuits using N9 multisim 14.3. That playlist you will go to get the basic versions of the how to open this app and all that we're going to show. Okay, and then go to the file and then save as. I already saved it as full wave rectifier circuits. Okay, and then we're going to take some time. Okay, I already saved. So basically, what are the components required for center tapered full wave rectifier without filter? First one, AC power. Okay, now I'm going to take AC power here. Go to the place component. Click on the right side of the mouse, right button of the mouse, and then uh, what is the component? AC power. AC power. AC power. We need AC power. So I type AC. Sorry for the inconvenience. It will going to say take some time. Please have a patience. Okay, AC power. This one, AC power. Yes. Okay. Place here. Thank God. And the next one, transformer. 1P. 1. Yes. Tapered. We want tapered transformer. Okay. All the components you should kept in the middle. Diode 1N400. Resistor. Okay. Let's do some connection. Yes. Yes. Ground. And then if I want oscilloscope, keep here. In the oscilloscope, we have two channel. I'm going to do negative, negative, sharp, and to the ground. Control C, Control V, copy paste. Yes. And then I'm going to connect A channel to the input here, and then B channel to the output. I'm going to change the output wire color red to blue for better understanding. Okay. Yes, I hope all the connections are completed. Now let's we change some voltage value and all. Okay. VRMS 120 and then here 50 hertz. You can change the VRMS also. I kept same. And then here 10 in the primary winding, 10 coil, 10 turns are there. In the secondary coil, secondary turns, secondary winding, 5 plus 5, 10 turns are there. So it works like a ideal transformer. So we should change the, we should make the transformer as a step down. So 100 is to 10. Okay, like 1 is to 10. If we give 100 volts in the input side, it will going to give 10 volts in the output side. So, okay, the very important point is we should make the ground between wire. Yes, tapping wire. Okay, now let's see run the code. Okay, our simulation. We should get pulsated DC. Yes, of course, we get approximate or perfect waveform. So I'm not going to concentrate on input, so that's why I kept a channel A is 0, and then I'm just concentrate on output. We want only VDC full load output. Okay. Yes. Oh, what is the how many numbers of boxes it covers? Almost 1.5, 1.5, 2, 2.5, 3, 3.5, 4. Okay, 1.4. What is the multiplication of 1.4 into 5? We should multiply number of boxes into voltage per division. So what is the value? 1.5, 1.5 into 5. Okay, what is the value? 7.5. So, okay, please write down. You can write wherever you want. You can write 7.5, 7.5 VDC, VDC full load FL, VDC full load. Okay, V suffix DC, V suffix DC suffix full load. That's how we need to write the notation. So 7.5. Okay, 7.5. So I need VDC no load, right? So that's why we should remove the so I want to rub the board. Yes. Remove we want to remove resistor. Select it daily. Puna run ಮಾಡಿ and measure the voltage. The no load voltage is should be greater than full load voltage. So count ಮಾಡಿ 1 box from zero margin or zero origin. You should take the reading 1 box, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. So okay, perfect value 0.5, 1, 1.5, 1.5. Remove 1.5 from 10. So 8.5. 1 plus, sorry, 1.85 into 5. So 9.25. VDC no load is nothing but, I hope all of you clear. VDC, VDC from here to here, 1.1 bucks plus 0.95. So 1.95 VDC no load, VDC no load is equal to 9.9.25. 1.95 into 5 is nothing but 9.25. Okay, rub the board. And for this value, you should do the calculation. We should do the calculation. How to do the calculation? I'm going to show you another one time. Another one time I'm going to show you. Please, all of you, keep it in your mind. So please go to the calculation part. Okay, what is the VDC? VDC no load value. VDC, sorry, full load value. VDC full load value is nothing but VDC full load value. Full load value is nothing but 7.5. I hope 7.5. Okay, 7.5. 7.5 you should write here instead of 5.93. VDC no load is nothing but what? 9.25. 9.25 VDC no load. Okay, here this value is not required. VDC no load 9.25. VDC as per our calculation. VDC no load is equal to 9.25. 9.25. So please replace here 5.93 into 97.5. VNL 8.7 is nothing but 9.25. Do the calculation. VM is equal to VD 5.93 into pi divided by 2. So instead of 5.93, you should put 7.5. Same like IM is equal to VM. What is the value we are going to do? Just put it here. RL is nothing but 12.2 kilo. So VRM is equal to VM divided by 2. IDC is equal to 2 IM divided by pi. VAC is equal to VM divided by root 2. IAC is equal to VAC divided by RL. Triple factor. How to calculate triple factor? Square root of IAC divided by IDC whole square minus 1 is equal to some value we're going to get, different value we're going to get. And then efficiency eta is equal to IDC divided by IAC whole square minus into 100 is nothing but some efficiency we're going to get same 100% this value we're going to get. And then load regulation is nothing but VDC no load minus VDC full load divided by VDC full load. Okay, VDC no load value 8.7 here, 9.25 minus 7.5 divided by 7.5 into 100, you're going to get some here 46% only. Okay, this is how we need to do the calculation. I hope all of you clear the calculation. Now let's move on to the next circuit, that is nothing but with filter. Okay, how to do the with filter circuit? Very simple. I'm going to rub the board now. Okay, yes. Okay, how to add the filter? Very simple. Go to the mouse and right click and right click. Okay, and then take down your, sorry, place capacitor. CAP. Capacitor. It will going to take some time because of, sorry for the inconvenience. It will going to take some time. I hope all of you understand. Okay, the first circuit is very clear, very simple. Full wave rectifier, that is nothing but that much is enough. Okay, now let's see dive into the second part in the first experiment, that is nothing but okay for center tapered full wave rectifier with filter. Okay,